Now let us try to understand how to draw complicated periodic function graphs. So we know what periodic functions are. So periodic functions are functions whose functional values repeat after a specific interval. That is, f of x plus some t gives you f of x back for all x. So if this condition is valid, we say that the function is periodic. And you have some standard periodic functions which you already know about. Fractional part of x is periodic with period 1. Sin x and cos x are periodic with period 2 pi. Tan x and cot x are periodic with period pi. Secant x and cosecant x are periodic with periods 2 pi. Now, in the topic of periodic functions in functions, we have already seen if some combination of these functions are given, how to find the period of the function. So, the period of function involves taking LCM of different periods. I'm not going to discuss that here, but if some sort of multiplication, addition, so on are done, some operations are done within these functions, you know how to find the period of the effective function. So what we are going to deal now is how to find the graphs if you have composite functions involving non-periodic and periodic functions. For example, if you want to draw the graph of y is equal e power sin x or e power fractional part of x, so e power sin x, e power fractional part, so. So whenever you have a composite function, as we have seen in the topic of functions, if the innermost function, if the first function into which x is going is periodic, the whole function becomes periodic. So composite function is periodic if the innermost function, innermost or the first function is periodic. That is, the first function into which x goes, if it is periodic, I can be very confident that the whole function is periodic. So if you want to draw the graph of e power sin x, so you don't need to think about the whole term. So you just need to think about one particular period. So let us take 0 to 2 pi. You have a pi here. So let us try to draw the graph of this within this period. So there is no direct shortcut to find the graphs of this. So we have seen different ways of transformation, but this is e power sin x is not a standard transformation. So what we do for general functions is we observe values. We observe values corresponding to different values of x. That is, we do the same thing as we draw a table. So now if you have e power sin x, so at x is equal to 0, we know that sin x is equal to 0. So y is equal to e power 0, which is equal to 1. When x is equal to 0, y is equal to 1. So I am effectively finding different values. As we know, as x increases, the value of sin x increases. As the value of sin x increases, the value of e power sin x also increases. So when x is equal to pi by 2, so sin pi by 2 is 1. So y is equal to e. So this is 1. And x is equal to pi by 2, the value of y is e. That is 2.7 something. So the value is going here. And next, when x is equal to pi again, when x is equal to pi, sin pi is equal to 0, y is again equal to 1. Y is equal to 1. Next, as you go into the third and fourth quadrant, the value of sin x is negative this time. So what happens at 3 pi by 2? Sine 3 pi by 2 is minus 1. So e power minus 1. So 1 by e. So you have some value here, 1 by e. And when x is equal to 2 pi, sine 2 pi is 0. So e power 0 is again equal to 1. So between 0 to pi by 2, sin x is increasing. So e power sin x also increases. Between pi by 2 and 3 pi by 2, sin x is decreasing. So e power sin x also decreases. So it comes like this. And between 3 pi by 2 and 2 pi, sin x again increases. So e power sin x also increases. So now this is the graph of e power sin x between 0 to 2 pi. Now we know that because sin x is periodic, the innermost function is periodic, e power sin x should also be periodic. So you just need to continue this graph over and over again. So as we go up, so again the graph looks something like this. So this is 4 pi. So this is as simple as this. So whenever you have a composite function for which the innermost function is periodic, the whole function becomes periodic. So what you do is you take one period, analyze the values of this function, and analyze the values of y. Try to draw the graph, a rough graph. You don't need to draw the exact shape of the graph. If you have rough graphs, that will be enough for solving questions. Next, so once you draw the graph in one period, just need to extend it again and again. So this is the graph of e power sin x. The same graph will repeat here also. So this graph can be extended backwards. So on like this. Right? Now, assume that you want to draw the graph of e power fractional part of x. So this is still more easy. Fractional part of x. Fractional part of x is a function with period 1. So you don't need to draw graph up to 2 pi also. You just need to draw the graph between 0 and 1. So when x is equal to 0, fractional part of x is equal to 0. So you get e power 0, which is equal to 1. And when x is tending to 1, when x goes close and close to 1, fractional part of x tends to 1. So e power fractional part of x tends to e. So if this is e, this is 1. So this graph goes up, and exactly at x is equal to 1, fractional part again becomes 0. So it drops down, and this is a periodic function whose arms are like this. So once you draw the graph between 0 and 1, you can extend it over and over again. So next, let us try to draw the graph of y is equal to log of sin x. Again, the innermost function sin x is a periodic function with period 2 pi. So this whole function will be a periodic function with period 2 pi. So you don't need to think about the graph or the whole domain. So you just need to think about the graph between 0 and 2 pi. Now the graph has to be drawn by analyzing the values. So now as x goes to 0, as x is 0, sin x is equal to 0, log 0 is undefined. So exactly at 0, the function is not defined. But close to 0, if x is in the neighborhood of 0, sin x is in the neighborhood of 0, sin 0 is 0. When x is in the neighborhood of 0, sin in the positive neighborhood of 0, sin x tends to 0 plus. So log of 0 plus, we know that it is minus infinity. So you're starting from minus infinity. And x is equal to pi by 2. And x is equal to pi by 2. So slowly the value of sin x has increased. So the value of log also increases. And x is equal to pi by 2. The value of sin x is 1. Log 1 is 0. So you have come up to 0 at x is equal to pi by 2. Next, what happens after pi by 2? Again, the value of sin x starts decreasing. So log x also starts decreasing. So it goes down, and when x is equal to pi, when x goes closer and closer to pi, sin x goes closer and closer to 0. So log of 0 goes to minus infinity again. The graph goes back to minus infinity. And between 0 and 2 pi, the value of sin x is negative. The value of sin x is negative. So log is not defined for negative values. So in this part, there is no graph. And this is the graph between 0 and 2 pi. So this is the graph which is going to repeat again and again. So between pi and 2 pi, there is no graph. Between 2 pi and 3 pi, the same graph happens. And between 3 pi to 4 pi, again no graph. So on. So this graph alternates, because the domain of this is only between 0 pi, 2 pi to 3 pi, 0 to pi, 2 pi to 3 pi, and 4 pi to 5 pi, so on. So I hope you understand how to draw the graph of log of sin x. Next, for example, you want to draw the graph of tan inverse of sin x. Here also the innermost function is sin x, hence the period 0 to 2 pi works. So again, let us try to analyze the values. When x is equal to 0, sin x equal to 0, tan inverse of 0 is 0. When x is equal to pi by 2, sin x is equal to 1, tan inverse of 1 is pi by 4. Pi by 4. When x is equal to pi, sin x is again equal to 0, tan inverse of 0 is 0. When x is equal to 3 pi by 2, sin x is minus 1, tan inverse of minus 1 is minus pi by 4. Sin 2 pi, 0, tan inverse of 0 is 0. So between 0 and pi by 2, sin increases, so tan inverse also increases. Pi by 2 to 3 pi by 2, sin decreases, so tan inverse also decreases. Then again it increases. Again, what I am saying is the exact shape in which it goes doesn't really matter. So you just have to know that the graph looks something like this. It is also a wavy graph. It increases initially, then decreases, then increases. And the range is minus pi by 4 to pi by 4. And this graph continues forward as well as backward.